Welcome everyone. So we've got our warm up for today. We're going to pause the video for a bit for you to try these two warm up problems. Number one, that's from the first day of the unit. So if you are stuck on problem one at all, feel free to look on page 2 of the packet and that might help you out. So we're going to pause the video for about 4 minutes to see if you could try these two. All right, so because G, F, and H are midpoints, F, G, G, H, and F, H are considered mid-segments. So if X to Y is 12, that means the mid-segment it's parallel to is half its length, so that is 6. If XZ is 20, then the mid-segment it is parallel to is half of its length, so FH is 10. And then our bottom side here, YZ we have is 24, so the mid-segment it's parallel to is 12. We then wanted to find the perimeter of this interior triangle. So if we add up the 10, the 12, and the 6, we should just get 28 for our perimeter, and they did not give us units in this question. In number 2, they told us RC was 16. We've got C to L is 10, and we've got TJ is 21. So that's this big part here is 21. The centroid, the key feature we want to remember is that it splits the median in a 1:2 ratio. Because we want to find RK, we're going to work with that 16. So the short part of the median, if you double it, it should give you the long part. So if RC is 16, that means CK has to be 8, and therefore RK, when you add those together, you just get 24. All right, going over to the homework. For angle bisectors, we want to look for those congruent angle markings. We had 3 sets of them here, so we could follow where those segments go to see where they meet. In B, we only had 2 sets of congruent angles marked. We had the single arcs for the angle for that segment, the double arcs here, so where do those meet? They meet at point Z. In number 2, the perpendicular bisectors, they all cross at the circumcenter. That is the point that is equidistant from the vertices of a triangle, which is why that's where we would want to put the drinking fountain in this case. It would be the same distance from all 3 of our landmarks. If our point of concurrency for the altitudes, so apple orchard, so think orthocenter, the orthocenter, if it's outside the triangle, we must have an obtuse triangle. The ones that involve a right angle, so the altitude and the perpendicular bisector, are the only ones that can change location. So the perpendicular bisector, which gives us the circumcenter, would also be outside. The other 2, incenter and centroid, would be inside because they're always inside the triangle. Moving over to the next page, we have, just like number 2 in the warm-up, we've got our centroid, so we want to think that 1:2 ratio. So if YW is 9, double that to get TY, which is 18, add them together to get 27 for TW. In part B, YU is 9, that's the long part. So the shorter part should be half that, so 4.5 for YZ, add them together to get 13.5 for the whole thing. And then Vx, they gave us the big part was 9. So pick a variable that's not in the question. Can't use X or Y, those are in the question, so I chose to use N. So I called the short part N, so the long part would be double that, 2N, and now I have an equation that I can set up, which is from our first unit. If you have a part plus a part, it should equal the whole. Solve for N, we get N is 3, so therefore the Vy is 6 and the XY is 3. 4 is that how the centroid is dividing the median in that 1:2 ratio. You could have said 2:1 also because they didn't specify the order of like small to large. And in the last one, GF was the whole thing. CF, based on the picture, should be the bigger one. So what I would suggest to do first is take all those and divide them by 2. So the choice one is representing what CF could be, and then the part in black is what CG could be. Together, they should add to this. Well, notice 2x squared plus x squared does not give you 6x squared. 2x squared plus x squared in B does not give you 6x squared. In C, 6x squared plus 3x squared gives you 9x squared. That's not what we want. In D, 4 plus 2 gives us the 6x squared. 6 plus 3 gives us the 9y. So we can do that basically by a little trial and error. All right, can everyone flip to the front of your packets? We are not doing the lesson for day 8 because it is an activity that I need to be there to walk you through step by step. So instead, we're going to look at day 9 in the video. So on your calendars, make sure to star that today's homework. What you're going to do tonight is the day 9 homework. So you're going to be doing packet pages 54 and 55. Okay, so the day 9 homework is what you are doing tonight. So it might come up in class today, but just a reminder, we saw it starting in our first unit, that our angles in a triangle, remember, add up to 180 degrees. We'll see that come up throughout the year. And we're going to start on packet page 49. So the first thing we're going to look at today is what's called the triangle inequality. And there's 2 ideas with the triangle inequality. The first has to do with the relationship between the length of sides and the length of the angle across from it within a triangle. So first we're going to share what it is, and then we're going to kind of use your hands to demonstrate to show why it makes sense. So I just drew ourselves a random triangle here, and I labeled the angles L, M, and S for large, medium, and small. Well, in any triangle, the large angle will always be across from the large side. So notice from the large angle, if I go across, that takes me to the large side. The medium angle will always be across from the medium side, and the small angle will always be across from the small side. And that'll be true in any type of triangle, any size of triangle. Now, if by chance you had a tie for the angle measures, so say you had 2 angles in a triangle that were both 40 degrees, then the sides across from those 40-degree angles would also be tied. And that's the idea behind an isosceles triangle. We'll end up talking about that eventually this year. But if the isosceles triangle has congruent base angles and congruent sides, since those angle measures are congruent, the sides across from them are also congruent as well. So this is the first part of the triangle inequality. Small side across from small angle, medium side across from medium angle, and large side across from large angle. And a way to kind of visualize that is put your hands together, lay one of them with the back of your hand facing down, and the other one with your back of your hand facing up. So like one right on top of the other. And you can be doing this right now in the classroom, even though I'm not there to see it. So you're going to put your hands one right on top of each other. So like palm to palm and like fingers to fingers. So where your hands are meeting near your wrist, kind of pivot one of your hands upwards, so right at the wrist. So it's kind of like opening up like an alligator mouth. And again, everyone can be doing this right in the room. What I want you to notice is that angle you're opening up is getting larger. Notice what's happening to the distance between the tips of your middle finger. As the angle amount grows larger, the distance between the tips of your middle fingers becomes larger. If you then start closing that alligator mouth, the angle of your hands is becoming smaller, and now the tips of your middle fingers, that distance between them is getting smaller. That distance between the tips of your middle fingers is just like the distance of the side that's across from an angle within our triangle. Guys, that's just a little way to illustrate why it makes sense that the small angle and small side are across from each other, medium and medium across from each other, and the large are across from each other. So that's one part of the triangle inequality. So let's go down to the bottom of page 49 and we'll talk about the second part of the triangle inequality. So what this part says is the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. Well, let's imagine we had a small, a medium, and a large side of a triangle. I'm just going to do S, M, and L, and you don't have to write what I'm writing in red right now. So the triangle inequality says if we add two of those sides, they should be greater than the third side. Well, if you add the medium and the large side together, obviously those are going to be bigger than the small because individually they are already bigger than the small. What about if you added the small and the large as your two sides that you add together? Well, obviously that's going to be bigger than the third side, the medium, because the large was already bigger than the medium. The only time it could be a mystery is if you add the small and the medium one together. That's the case where it could fall apart because the small and the medium might not add to be greater than the large, that third side. Now notice it has to be greater than, it can't be equal to. So I'm going to illustrate this idea. I want you to think of like a drawbridge. And I got a couple pictures drawn here that aren't on your packet. So let's work with the one on the left. So I've got this bottom side, which is our large side. And just so you know what I'm talking about, we're working with that picture right here. So I've got this bottom side, which is the long side, and then I've got a shorter and a medium one that are at certain angles. And I want us to envision like a drawbridge. A drawbridge, so just in case you don't know what a drawbridge is. So a drawbridge basically has like a split in the middle, a big boat comes in, and the operator of the drawbridge lifts up each of the sides of the bridge so that then our boat can travel through. I don't know if that illustration helped at all, may have made it more confusing, but basically it opens up at the middle and ends up going, may go straight up or at least go up enough that a boat could pass through, say something with like a tall mast. So think of a drawbridge when we are thinking through this. So what I'm going to do is I'm going to kind of swing this side trying to keep it the same length. These are like all the different angle measures that we could have over on this side for the triangle. If I do the same thing over here, if I kind of swing that back and forth, notice there is no way for these sides, if I kept them the same length that they currently are, to meet up and form a triangle. But if I go over here, as I swing these ones, again, I'm trying to keep them roughly the same. If I move my finger a little too much, they will switch. But if I move those, notice that they will come down and hit into each other and basically prop each other up. So on the right, we have a scenario where the sides form a triangle, but on the left, we have a scenario where the sides will not form a triangle. Well, on the side on the left where they're not forming a triangle, if we added these two side lengths together, like if I laid them flat, they're going to go like right there and right there. So those two purple links together are not greater than the third side, so that's why a triangle cannot be formed. So basically there'd be like a gap in that drawbridge as it's coming down. Whereas the one on the right, because these two sides, if you add them together, are greater than that third side on the bottom, they're going to prop each other up so they can form a triangle. So any two sides in a triangle have to add up and be greater than the third. And the one that could run into a problem is if you add the small and the large, or sorry, the small and the medium, they have to be greater than the large. All right, so let's imagine we had 6 and 9 for our two sides and we wanted to find the third side. So I'm going to list two scenarios. Imagine we had a side smaller than 6, 6 and then 9. And imagine 6 and 9 were the smaller ones and we had some unknown big one. So let's think about this small one. Remember, if we add these two together, they have to be bigger than the large one. They have to be bigger than 9. So therefore, 3 is what would make them equal, but we need it to be Not equal, we need it to be greater than. So therefore, 3 still isn't quite good enough. So what we would do is we would want our x, our side, to be greater than 3. Well, if I go over to the other one, if we're considering 6 and 9 the small two, and we want them to add and be bigger than the other one, well, notice 6 and 9 together are 15. We need 15 to be bigger than this third side. If 15 was there, they'd be equal to, so that'd not be any good. So we got to make sure that third blank is not bigger than 15. So that's where the second part of this inequality is. So when you have a two-part inequality like this, notice both signs are opening towards the bigger thing. So on the lower end, our lower bound, our side has to be bigger than 3. So that number plus 6 will be greater than 9. And on the high end, we can't be as big as 15. We got to be smaller than it. So that 6 plus 9 would have to be bigger than that number. Now what I want you to do is I want you to think about these numbers 3 and 15, because that was a little complicated to think through how to get them. And I want you to think of the numbers 6 and 9. What could you do to 6 and 9 to get a 3? What could you do to 6 and 9 to get a 15? And I'm going to go ahead and pause the video for exactly 1 minute. And I want you, with the people in your row, see if you can come up with what would you do a 6 and 9 to get a 3? What would you do a 6 and 9 to get a 15? So go ahead and discuss that now. So hopefully to get the 3, you talked about how you could take the difference between 6 and 9. So 9 minus 6 gives us the 3. And to get the 15, you could take the sum of the 6 and the 9. The 6 plus 9 gives us 15. So do the difference to get the lower bound, do the sum to get the upper bound. So we're going to practice this with a couple of examples here. We're going to write an inequality that could represent all the possible lengths of the third side. So we're going to have something less than, and we'll go with x again, less than something. To get this lower bound, just subtract the 2. So 11 minus 7 gives us 4. So our lower bound of the inequality would just be 4. If we add them, 11 plus 7, we get 18. So the upper bound would be 18. So this would be our answer here because it's all possible lengths, including decimal lengths. So we just talked about the integers that were the lower and upper bounds, but what that inequality is meaning is all the integers, all the decimal values, all those in between could be possible third lengths for the triangle. All right, if we try this next one again, I'm going to do our inequalities. On the lower end, 9 minus 4 gives us 5. On the upper end, if we add them, we get 13. So any sides that are bigger than 5 but staying less than 13 would be able to make a triangle with sides of 4 and 9. We're not going to pause the video. We're going to keep it rolling, but I want to see if you can, in 30 seconds, figure out what our answer would be in example 4. So if we subtracted, we would get 2. Less than x, less than. And if we added, we would get 32. So as long as x stays in between those two values, okay, can't equal them, has to stay in between, then we could make a triangle with those side lengths. All right, let's go over to page 50. Another way we could work with the same idea of the triangle inequality is being given a length of sides and just knowing whether or not they could make a triangle. Well, if you remember on the previous page, I talked about the place where it could run into trouble is when you add the small and the medium one. So in this list of 5, 7, 13, we're going to take the two small ones, the small and the medium, and we just want to add them and see if they're greater than 13. So we're going to have 5 plus 7. We want it to be greater than 13. Well, that'll give us 12. It needed to be greater than 13. That's not true. So we would say no in this case. For the next one, take your small and your medium, 48 plus 52. We need it to be greater than 100. Add those up, we get 100. Is it greater than 100? That's not true, it's equal to. So therefore, this would also be a no. If we had had in this example, say 48 and 53, well, now we have 101, and now we would be in good shape. So we're going to add two more examples. We're going to have you add on your page to see if they're yeses or nos. We'll call this example 3. Let's say we had 5, 5, and 7. And example 4, let's go 4, 9, and 5. And we're going to pause the video for 1 minute, see if you can decide whether or not these 3 links could form a triangle. So go ahead, try that now, and you can check with the folks in your row. So for example 3, notice we have a tie for the small and the medium. That's fine, just add those together. The 5 plus the 5 would need to be greater than 7. That would give us 10, which is greater than 7. So this would be a yes. Now, if you had an equilateral triangle where they were all the same, like say it was 5, 5, and 5, you would just pick any 2 of them to be the small and the medium one. Now, the thing I tried to trick you with in example 4 is I did not list them in ascending order. So we want to check the small and the medium added together. So this would be 4 plus 5. Is that going to be greater than 9? Well, 9 is not greater than 9, so this would be a no. It needs to be greater than, so they prop up when we're thinking like that drawbridge. All right, so we're going to see if we can apply this a little bit now. Each of these questions starts new, fresh and new again. So we have a single picture to the right that we're going to use for all of these questions. So it'd be best if you're working in pencil so that we could erase after each question. So they tell us angle A is the largest angle. So I'm going to put an L inside angle A. We then want to know the longest side. Well, large angle is always across from the large side. So therefore, our largest side is going to be BC. So working back to notation from Unit 1, when you name a segment, you name it with capital letters, and then you just draw the segment above it. It would have also been okay to call it CB. So we're going to erase what we just did over in our picture, and we'll now go on to number 2. So we'll label the things they tell us. We've got AC is 7, we got BC is 6, and we've got AB is 4. We want to know what's the smallest angle. Well, the small angle should be across from the small side. 4 is the smallest side, so the angle across from that would be angle C. So do your angle symbol and then put C. It should be a capital letter. We represent our angles with capital letters. Now, it would be okay to use 3 letters here as well. 3 letters is always okay. So you could say angle ACB or angle BCA. But because there is only one angle happening at C, it is okay to use just 1 letter. So let's erase, and we'll relabel for the new one. We've got angle A is 64. We've got angle B is 35. And we want to know the longest side. Well, something we've learned today is the longest side should be across from that largest angle. However, we only know 2 of the angles. In order to determine which angle is the largest, we would need to know what that third angle is. And this is where the quick review I did earlier comes into play. Remember, our angles in a triangle add up to 180. So what we're going to do is we're going to pause the video for 1 minute. You need to find that missing angle so that then you can make the determination of which is the longest side. When you state the longest side, make sure to use our proper notation with capital letters and putting the segment above it. So we'll go ahead and pause for a minute for you to try and figure that out. Feel free to use your calculator if you needed to use it. All right, so together these give us 99. 180 minus 99 would give us 81. 81 is now the large angle. So therefore, the large side should be across from it. So you could either have AB with your segment line above it or BA. You can reverse the order of your letters in a segment or a line, but not array. All right, we'll erase for that. We might not need our picture for these two. So we've got 6 and 4 are two sides in a triangle. What could the possible length of the third side be? Well, let's do our three-part inequality. We'll subtract to get the lower bound of 2. We'll add to get the upper bound of 10. So note it cannot equal 2 or 10, but as long as our third side is something in between there, it is guaranteed those side lengths will be able to form a triangle. Because again, think that drawbridge picture, that means that they would prop each other up as they were kind of bending downwards. We're going to keep the video rolling, but we're going to give you, say, 45 seconds to see if you can try E. So on our low end, when we subtract them, we should get 7 is less than x is less than. And I should mention, you could use a different variable if you wanted. We've just been using x to represent the missing side, and add them to get 17 for the upper bound. All right, so we've talked about the two parts of the triangle inequality. Small angle across from small side, medium angle across from medium side, large angle across from large side. That's one part of it. And then the idea that if you add two sides in the triangle, they have to be greater than the third side. Those are the two different parts of what's called the triangle inequality. The one other thing we're going to look at today is what's called the triangle exterior angle theorem. So we're going to show you the triangle exterior angle theorem. We're not even going to talk about the stuff above yet. What we want to prove eventually is that angle A is equal to C plus D. Okay, and we'll get to why that is in a second. So let's start some things we know. Angle A plus angle B should equal 180. And that's because angles on a line add to 180. We know that angle B plus angle C plus angle D should equal 180 because those are the angles in a triangle and they should add up to 180. Well, because they both equal 180, through substitution, they should be equal to each other. So A plus B should be equal to B plus C plus D. Well, notice we have a B on both sides. So using opposite operations, we can subtract B from both sides. And notice what remains is that angle A is equal to angle C plus D. So let's talk about what's meant by that. This is what's called the triangle exterior angle theorem. If you have an exterior angle in a triangle, okay, an exterior angle is formed if you have any triangle, and imagine you just extended one of the sides. That creates an exterior angle. So where my star is, that's the exterior angle. That angle is equal to the sum of the two interior angles that are not next to it. Sometimes those are called the remote interior angles. But the exterior angle theorem is saying that black exterior angle there, which was formed just by extending one of the sides in the triangle, should be equal to the sum of the two interior angles, those green ones, that are not next to it. So we're going to go down on the bottom to part B to see if we can apply that. Notice the 7x minus 48 is an exterior angle because it's the angle formed by extending one of the sides of the triangle. So that 7x minus 48, that should be equal to the sum of the two interior angles that are not next to it. So we'll have it equal to 3x plus 2x. Since we have an equation now that's true, we could solve in order to find x. So this would be 7x minus 48 equals 5x. I'm going to subtract the 7x over. We'll get negative 48 equals negative 2x. And we'll divide by negative 2 and we get 24 for x. Now if we recheck the question in the directions, x is all they wanted us to find. Sometimes they will want us to sub back in to find a specific angle, specific segment, depending what we're working with. But in this case, we just wanted to find x, so we're in good shape. All right, if we go over to the next page, similar idea here. Notice we have another exterior angle that was formed by extending a side. The exterior angle should equal the sum of the two interior angles not next to it. So that would mean that x squared should be equal to 8x plus 20. So the setup is same idea. Exterior angle equals sum of the two interior angles not next to it. Difference here from the last problem is we now have a quadratic equation. So this goes back to what you did in algebra and we reviewed in Unit 1. When you have a quadratic equation, we want to get it equal to 0. So we're going to subtract everything over to be with the x squared. We like a positive squared term. That's why we chose to bring everything over to the left with the x squared, which was already positive. To factor, we've got to do our little math riddle. Now I want to point out something in this black step that I just wrote, that on problem sets, sometimes on tests, I'm not seeing good enough notation. When you factor, if it was an equation, we still need that equals 0. The equals 0 is what's allowing us to solve this. If you didn't have the equals 0, then technically you couldn't solve anything. So we got to make sure we're carrying down that equals 0. We want to multiply to our constant, the negative 20, and add to our coefficient of the x, the negative 8. If you're unsure of how to do that, remember you can take the number you want to multiply to and divide it by x in a graphs page and then do a Control T, and the table will show you all the factors that multiply to negative 20, and then you would just have to find which ones would add to the negative 8. But in this case, we'll have negative 10 and a positive 2. We should then set those each equal to 0. Doing opposite operations, we get x equals 10 and x equals negative 2. This is a carryover from the previous page where the directions were just find the value of x. But keep in mind, whenever we get two answers this year, we've got to check because sometimes one of them might get rejected. X squared, 10 times 10 is a positive number, that's fine. Negative 2 squared, a negative times a negative is a positive, that's fine. But we do run into an issue with the 8x. If you do 8 times negative 2, it gives you a negative angle in a triangle, and we can't have that. So we're going to reject the negative 2. We did not reject the negative 2 because 2 is negative. We rejected the negative 2 because it gave us a negative angle in our picture. So our only answer then would be the x equals 10. All right, that's where we're going to stop for this video. Remember, your homework is the day 9 homework, the packet page 54 and 55. Have a great rest of your day.